Alright, hello everyone, this is TopCog here. In this video I'm going to be doing some coding on my new project IdleManager, and hopefully I'm going to be coding up the idling components, or the offline capabilities for the new game. And I'm just going to try to give some commentary on what I'm doing, why I'm doing it, and yeah, hopefully you learn a thing or two, and it's fun to watch. So here we are. The first thing I'm going to do is code up the idling for the dojo. I'm trying to run it right now and give you a little bit of overview of what the game looks like and what we're going to try to do. At the dojo, you invest gems, and okay, so here's the game. Here's the dojo. So, okay, in the as you mine, you're breaking regular dirt blocks. You're breaking ore blocks. That's these, the ones with some gray, dark area there. And then you're also mining gem blocks, which, let's see if we can find some. Yeah, like this. So you mine the gem blocks, and then up here, it's all very crude interface at the moment, but bear with me, and then your gems increase as you collect the gems. At the dojo, you choose some investment rate of your gems. This should say gems per second. That should say, yeah. So you choose some investment rate of your gems, and that results in a increase in your raw stats. So you invest the gems, and the gems, based on your investment rate, you raise your raw stats. Let me actually give you a little bit of an example here. So let me go to Debug Manager, and let me reset the stats. Let me reset this game. It should work, and then it'll reset all the stats, then you'll be able to see a little more clearly how the training works. Okay, so now I have 0 gems, I have 1 muscle, 1 reflex, 1 wit. Those are my raw stats. And then your strength, dexterity, and intelligence, those are your vital stats. And then your vigor, finesse, and wisdom, those are your deep stats. That's not really important at the moment. The main thing I wanted to show you is... okay, let me do this, get back to the start of the game. I guess my reset function doesn't reset everything entirely. Alright, so I just want to find a few gems, then you can see how the investing works. Actually, you know what? Let's just do this. Let's just cheat ourselves some gems. I think... yeah. No, that's not it. Alright, so let me quickly let me figure out how to add gems effectively. Okay, so yeah, it's pretty simple. Just gonna add like this. Let's just give ourselves 1,000 gems. Let's do it 100. So the reason it looks like normally you just do something like this to add 100, but I use a custom number format called N, capital N, so creative of me, and it stores numbers as long as exponent, long value for the exponent, and then a double floating point precision for the coefficient out front. I forget what the name of it, the mantis, something like that. Okay, so let's try this again. I have 100 gems, and you should see the gems go down steadily, and then you'll see the raw stats going up. So yeah, gems going down slowly, raw stats going up. And if I increase the investment rate, okay, 2 per second. Okay, so now it's okay, I'm spending 2 gems per second, and the raw stats are going up 2 per second. The raw stats, what they do, I'm not really going to cover in this video. It's pretty complicated. But it's one of the basic ways of progressing in the game. So you invest gems, and the gems raise your raw stats. What I want to do in this video is put in the idling capability so that if I shut down the game, this investing will keep going. and then when you come back to the game, you'll have invested however many you should have invested over that amount of time. Okay, so that's what we're trying to do. That's the objective. So I'm going to add a new class here to logic. Let's just call it the IdleManager. I guess it's not really a manager. Idle. What would be a good name for it? IdleManager. Just idle logic, I guess. Well, I like manager. I use the word manager a lot. It's good. Alright, let's just add some class here. Idle for some amount of time. And it's going to be some amount of seconds that we're going to idle for. Okay. And let's just put in some debug code. D is my just standard, just shorthand for system.out.println, and yeah. So let's idling 4 seconds. Okay, and then what I'm going to do is just format this. Capital F is my shorthand for formatting time. Okay. Format long time, checking to see if this accepts milliseconds or seconds. Just seconds. Okay. So we're good. So idle for that amount of time. And we got to call this function after we load the game and then whenever the app resumes. So preference manager. And the amount of time we're going to idle for is based on actually some various things. Where is this? Okay. Thought I was saving. Looks like I'm not saving the value that I need to, so I need to save, when I save the game, the current time. And actually I have some more complicated code that handles the time management, which I'll integrate into the game at a much later time, and that code is to prevent against time warping hacks and things like that. Probably not going to share that on here just so it's not super easy to cheat at the games. It is possible to bypass the preventions, but this will work for now. So save, time of the save, and then when the game is loaded, do the converse, and let's put this value just in this file for now. And we'll figure out how to use it in a bit. Okay, so load the game, time of last save equals get, and the default value will be this. The way this function works is this is a libgdx function. This is the name of the parameter we're saving, and then this is the default value if it's void or null. So okay, all right. So then we do the loading. That calls this function, loads it. We get the time of last save, and then the time we want to idle for is the time of the last save minus the current time. And that would be in milliseconds. So let's get that in seconds, just divide by 1,000. Stick a F in there to make sure it gets cast to float, otherwise it'll be long and we'll lose, well, I guess we'll lose 1 second of precision, not a big deal. Okay, so this should work. And let me pull over my console. So this isn't the full solution yet for calling this function, but let's just see what happens when we run. Okay, so idling for 0 seconds, that's expected because the value was 0. So now if we close it down, wait a few seconds, launch it again. It should run this. It should call this, and we should see it saying something. But it's not. Idling for 0 seconds. Time of save. Oh. Okay, well that shouldn't be there. Pref.put long, time of save. Pref.get long, time of save. Time of... Okay, so let's check what is this value. And if this doesn't work, we can always slap a breakpoint in there. Alright, so 1.48 e to the 12. Okay, so... got these backwards. Current time should be greater than the old time, right? I think the time formatting probably doesn't accept negative. Hopefully that's all that's happening. Alright, there we go. Idle for 131 seconds. Of course, I don't think we actually did, so let's see if it works this time. 0 seconds, okay. 1 1000, 2 1000. Actually, let's just run it and see. Idling for 0 seconds. Alright, so let's do this. Time for last save, and let's also see what the current time is. Current time in milliseconds minus time of last save. Time of save is put. Why is this not working? Alright, so time of last save. Load should go here. Time of last save. Time of last save 1.48. Let's just see what this says. Alright, this is kind of weird. Are these values the same? 1, 2, 3, 5, 6, 7, 8, 9, 10. Yeah, they're the same values. Time of last save is a float. Current system time in milliseconds is long. No, they're not the same. There's a 3, 3, and it's a 3, 8. Not sure why this. Am I losing precision because of the float? Yes, I am. I think what I actually want to do is make time of last save long. And we don't even need. We'll just accept the 1 second error in the idling time duration. Okay. Closer. 6 hours of idling time. Oh, that's right. That's because this is accepting seconds. Alright. Oops. I just ran it twice. Okay, idle for 10 seconds. That is what we're looking for. Alright, problem solved. So, yeah, it's the kind of things you run into different variable types and making sure you got the right thing. Okay, so it's now calling this function at the right amount of time. I also want to add this to when the game is resumed. So when the game being resumed is on your phone. If you leave the game running, if you hit the home button and it minimizes the game, excuse me, if you leave the home button, minimize the game, what that does is pauses the game, but doesn't dispose of it. And then when you come back, it will, well, I'm going to have this work a lot differently than I have in my previous games. It's not going to reload the game when you resume. It's just going to continue where it left off. And I have to do things a little bit differently to make that happen, but it should be fine, and I think it's going to work well. So the way we're going to do this now is when it, let's see, how do I undo this? It always saves the game. So it's still going to have the time of lapse save. Yeah, so this is, just call that same function. Yeah. Resumed. Now, one thing I need to check is I think when the game starts, the way the Android flow works, I think it might actually be calling resumed at the start. It is not. Okay, good. And if I click off screen, you can see paused, saving. Now if I come back, resumed, idle. Although it should not have idled for 105 seconds. So, alright, let's figure out what's going on. Why is it saying pause for 105 seconds? Pause should be going here. Pref save. Oh. Okay, so actually what I want to do is whenever you save the game, also cache that value. Yeah. Should do it. And this is taking a little bit longer than I was expecting, so we might just only get through half of the idling stuff that I was wanting to do, but that's fine. Okay, so idle for 42, idle for 44. Still not doing it. Idle for 46. Time of last save. What is going on? Paused, saving, resumed, idling. I mean, technically it should say idled. Well, let's just look and see what value we got here, what value we got here. Just see if something's going on. Maybe there's another step I'm forgetting. Obviously there is. Okay, so 803. It's 5. It's the same number. It's the same number, but it should be changing. Because, okay, let's check here. It's the same number. Public static long time of last save. Time of last save, when you load the game, okay, when you save the game, time of last save equals, oh, okay, it's loading the value. I actually want to set the value. Yeah, I messed this up. There we go. So when you save the game, it sets it, and yeah, that's what I meant to do. But did not. Okay, now it seems to be working. 2, 3, 2 seconds. Okay, excellent. So now I'm going to take out these debug statements, and okay. All right. So now we've got it calling this function with the appropriate time after we idled. Now we need to put actually in the logic. Okay, so now dojo idle logic. Okay, so the dojo should have some investment rate value that we need to get. My sprite investment. Actually, okay, it's not the dojo. That's the training manager. Training manager dot investment rate. This is the gems per second. So I think this is pretty simple. Let me first check and see if gems are stored as a double or as the custom number format. Yeah, they're custom number. So just make a quick new variable, custom new object of n that we can use however we like, and n is going to be, this is going to be the total. I guess we can rename it. Total gems. Total idle gems. Alright, so the idle gems is going to be the investment rate times the time we've been away. Pretty straightforward. Q is sets equal to. That's what that means. So total idle gems dot Q training manager investment rate. That sets total idle gems equal to training manager investment rate, and then dot M multiplied by seconds. Okay, but if the total number of gems we have is greater than our current number of gems, resource manager, not the greatest name of something. And the way the comparisons work is total idle gems dot compare to, and then another value, and then you're always going to have 0 on the right hand side of the inequality. And if it's less than 0, if I write less than 0 here, it means is total idle gems less than resource manager dot gems. So if it's not, let's do it's not first because that's easy. That means resource manager dot gems, subtract out the gems, and then actually, you know what, let's do this. We're always going to be subtracting gems. If it's less than the total gems, then if we don't have enough gems, total idle gems is going to be equal to resource manager dot gems. Okay. So now this for sure has the number of gems we've used, we've invested while we were away. So we subtract those number of gems, and then we invest that many gems. To do that, let's go ahead and make a new function in the dojo and just say invest gems. Actually, not the dojo. Dojo is UI. Training manager is what we want. Invest gems, total idle gems. Just make this a new method. And let's actually put this in that method as well. Yeah, I'm not sure if this is that useful, but it kind of makes sense to do it this way, so we'll do it this way for now. So this is invest gems like instantly, this many gems that you have. So it's going to subtract those gems from the gems we have, and then it's going to increment our oh, actually there's a function delete gems, which is a little bit better. Refresh stats, refresh power. So actually what I'm going to do here is take all this code. This is the code that happens every tick, every second, not every tick, every second. This investment rate n, it's double. Actually, I don't even need to do that, do I? Okay, well, gems to invest. This is the way I want to do it. Gems to invest. And here, the amount of gems we're going to invest. Invest gems is gems investing.q investment rate. I know the names of things are not really making a lot of sense right now, but I can always fix that up later. Okay. So this is good. Just compacts thing a bit. things a bit, makes it better. And then I got to change this function to now accept n. Okay, good. So that should work. IdleManager, and let's give ourselves some debug info. And we're going to format this to make it readable. We don't need decimal. Okay. Yeah, that should do it. Should be pretty. That's pretty straightforward, actually. Let's see if it works. Okay, idled for 6.28 minutes. Invested 337 gems. Oh, I have negative gems. How wonderful. Alright, so obviously shouldn't have negative gems. Let's give ourselves 1,000 gems. No, let's give ourselves 1 gem. It's just when we restart the game. Post load. Where is this happening at? Post load. Yeah, it's gonna do this code first before it gets to here. So I want to see if I can reproduce this error, or once we fix the error, we need to test to make sure that the error is no longer happening. So let's see. IdleManager, if total idle gems that compared to resource.gems is less than 0. It's not less than 0. Let's also just see real quick how many gems we have. Why is this happening? One gem, but we invested 70. Alright, so clearly there's something wrong right here. If total idle gems that compare to... Oh, no, this is backwards. Let's rename this to be easier. Gems... let's say max gems to... this is the number of gems we... okay, max gems to invest while idle. I don't know, something like that. So let's just change this around a bit. Yeah. So if the number of gems we're going to invest is greater than the number of gems we currently have, then chop it down to be the number of gems we currently have. That's what we want to say. There we go. Idle for 48 seconds, but we only invested 1 gem, and you can see our muscle is 2. So if we run this again, let's just suppose 5. Our muscle should go up to what? 7, right? IdleManager, if we wait, if it was assuming we waited 5 seconds. So our raw stats were 2. They're still 2. So it said we invested 5 gems, but we didn't. Our stats did not go up. Ah, okay. Raw rate. Ah, okay. Okay, that's right. Investment rate is not the same as the stat gain rate. So we may have been... Okay. We need to change this around a bit. I was pre-calculating, so based on the number of gems that you invest, you're getting some equivalent increase in raw stats, but there's diminishing returns. So if I invest 1 gem per second, you're getting 1 raw stat per second, and it's got some polynomial factor, like x to the 0.8 or something like that, x to the 0.8 power. So if you invest like 10 gems per second, you're only going to be getting like 8 raw stats per second. So I need to... Okay, so this actually is more complicated. Okay, so this is much more complicated. So if I'm investing at 1 per second, it's a linear rate, then what I've done would work, right? You invest idle for 100 seconds, invest 100 gems, your raw stats get boosted by 100. Simple. But what if I invest 100 gems in just 1 second, right? And then I would run out of gems in 1 second, but my rate of return would be far less. So actually I need to be calculating the raw stat gain in addition to the gems invested. Okay, I think I see how I need to do it. We're going to come back here, and this is probably going to get all changed in a bit. For now, let's stick in the IdleManager. So this is the max gems to invest, like assuming we can invest at our current investment rate, right? So this up to here, it's still good. This is gems we have invested. Let's just say gems invested. So up to here, we're good. That's how many gems we've invested. Now we need to calculate from that how many stats have we gained. And the way to do that is Training Manager has, it calculates the rate of return that you're getting, which is called the raw rate, raw stat rate, which it calculates once. Anytime you change the investment rate, it just calculates this, and then yeah, it's easier to do it that way, and then it doesn't have to calculate it again every frame. I'm still not happy with how this is separated like this. Gems to invest, because this is not actually investing this many gems because of the raw stat. I'm gonna move this back. I don't think this is actually serving any purpose right now. Right, because now once, let's just make this, overload this. Alright, that's good. Okay, so I need to make sure that we're setting the raw rate at the right time. Set raw rate happens at reset. Set investment rate. Alright, so I think when we load the game, actually we need to add an extra step. Do we? Yeah, we do. Training Manager needs to set the investment rate. Well, it does, but this actually accepts a parameter, which is the position along the bar that we are. Actually, let's just call the raw, let's just do this for now. And it's going to tell me that's not public or something. Yeah. Okay. Good. So I just saw that error when it loads the game. It's not setting the raw rate, the raw stat rate. So now it is. Actually, we can do this one better, right? Set raw stat rate. Okay. So now the raw stat rate is set by the time we get to this point. So now we want to find how many times are we investing per second. So it's simply gems invested divided by Training Manager.investment rate, which is going to be the same as the number of seconds unless this condition is met. So yeah, so this is no longer gems invested. This is actually a time, right? Seconds invested. Let's convert this to double. This is seconds invested at the investment rate. And then the raw stat gain we're going to get is equal to equal to the raw stat rate, which we already calculated, times this number of seconds. So I think it makes the most sense to have this say invest for time. Invest over time, and let's give it the seconds invested. I think this will work. And then now we can take this up here. We can say invest over time for 1 second. Take all this, pop this down here. And the depletion is going to be the gems, the investment rate times seconds invested. And this is probably going to have to become an N, a more larger number format depending on how big the numbers get, but I'll worry about that later. Okay, so, and now all these things get multiplied because the raw rate is in terms of seconds. And the reason I want to have all this in its own function is because I can call you know, these kind of things which have to recalculate a bunch of stats and recalculate the UI and etc. every time that you change one of these raw stats. Okay, I think that is actually going to work. So, but I still want to get some time or some debug info. So let's set up the debug info. Investing that many gems. Equivalent seconds. Horrible at spelling. Equivalent seconds, I think. Okay. Format long time. Seconds invested divided by... Nope, it's just format seconds invested. And then... Oh, do I really want to do this? Okay, let's just do this real quick. We'll just do it real quick. This is... Let's not even make this a final. It's okay if it gets garbage cleaned. N equals new n. It's just like some temp variable. I want to see how many stats we gain. So first I'm going to cache the value of the muscle and then subtract out new value and multiply by -1. Do I have a function negate? I do. How is that useful? Slightly faster. Okay. And then let's just print that to the screen. And it should do the f.format automatically. Let me check this real quick. Or toString, yeah, it does that automatically. So, okay, so I think I can actually just do this. No, I can't. It's a different function. ToString, the way it does the ToString is it prints out both variables differently. Okay, I'm sorry that was it's probably a little incoherent rambling, but hey, it's my first time doing commentary while I'm coding. Alright, so all this should be the Dojo idling logic. Let's run it and see if it works. I think I still have the... Okay, this isn't going to be too impressive. Alright, idle for 8.45 minutes. Investing 5 gems, equivalent seconds, 5 seconds. Stat gain 5. Looks like it worked this time. So let me give myself 50 gems. And let's say that my investment rate is 10. Okay, let's just put that in there, investing at that rate per second. Let's just say invested. Okay. So now, we probably idled for over 5 seconds. Idled for 46 seconds. Invested 50 gems at 10 per second. And equivalent of 5 seconds. That's correct. Stat gain is 28. Notice that it's not 50 because we're getting some lower return. Let's actually say at 10 per second and Let's just call raw stats RS. Okay. I don't even think we care about this. Seeing that. Excuse me. Ten gems per second and 5.6 raw stats per second. So 5 times 5.6 whatever is 28. Okay. Looks good. And I think the reason it's not still investing is if your investment rate is higher than your current gems, then it does nothing. This needs reworked and improved a whole bunch. But now I set it back to 1 and it's going. Alright. So I think that's going to do it. Pretty cool. I think that's going to do it for probably this video. I did want to code up one more thing with the idling, which is the proficiency and the mastery. But I anticipate that actually has a lot more difficult math. And it's a lot more complicated to explain. Well, let's take a look at it real quick. It might not be too hard. Okay, so this looks to be working. To summarize, let's just clean this up a bit. Alright, so let's try this real quick. Proficiency, because I think now that we're in the groove of things, it should go pretty fast. Maybe. Okay, so the proficiency, I'll explain this. Okay, so every time you break a block, every time the ninja breaks blocks, it gets combat experience. And the combat experience adds to your combat mastery, which should not... Oh, it's resetting every time, okay. Adds to your combat mastery, and it adds to your weapon proficiency. So combat XP adds to your combat mastery and weapon proficiency. The higher your weapon proficiency, the higher your proficiency damage bonus. And that is linear multiplier to your damage, to your power. It's linear multiplier to your power, and your power is linear multiplier to your damage. So every time you break blocks, you're getting progress towards increasing your mastery and your proficiency. So that's your proficiency, gives you proficiency bonus. Every time you forge a new weapon, it resets your proficiency back to 0. And so your proficiency bonus goes back to 1, which does nothing, right? But your mastery does not reset. Might never reset unless, until some very late game prestige. I've got some ideas to use mastery as a kind of resource which you can spend on some permanent buffs or a buff tree or something like that. We'll see. Cool stuff. But for now, your mastery does not reset. And the purpose of your mastery is your proficiency slowly increases back up to the level of your mastery even without breaking blocks. So if I recall right now, you can see it's slowly going up still. Yeah. So I want that to happen even while you're offline. Your proficiency to still increase up to your mastery. A lot of difficult math here that went into this equations. I guess not as bad as some of the training math. It's not too bad of math, but hopefully I can explain it, and there might be some errors along the way. So first, just to see how we got to do this, we got to get into the nitty gritty a little bit. So Proficiency Manager. So you gain experience when you break blocks, but we're not interested in that right now. What we're interested in is every 1 second, our proficiency is increased by some amount based on our current proficiency and our current mastery. The larger the difference between your proficiency and your mastery, the larger the bonus you're going to get. So what we're interested in is actually this function called once per second, called every 1 second. All right. So the way this works, I guess I have to talk a little bit about how you gain how the proficiency scales. Proficiency scales with, as I said, every time you break a block, and every time you break a block, you get some amount of experience, which for now, that experience is determined based on your intelligence, which is one of your stats. Your intelligence divided by 10, technically. Your intelligence is a stat which gets raised through the dojo by training in similar to the manner that we just looked at. Bottom line is your intelligence grows exponentially as you progress, and it grows with a base value of 1.152. So, hold on 1 second. Let me pull something up. Right. So, yeah. So the base to some variable is your intelligence. Your intelligence is equal to this base raised to some power. This is the expected value. This is how the expected value of your intelligence should grow. And this parameter up here is something to do with the current layer that you're in. So the further down you dive, your intelligence should grow exponentially at this rate. So yes. So likewise, your experience, since your experience is based upon your intelligence, your experience is going to grow in a very similar manner. Actually, this is the thing we need to look at. What is your par experience? By par, I mean expected values. The expected value of your experience based on the layer that you're in. The layer is how deep you are in the world. And this value is equal to, it's pretty simple, it's the expected value of your intelligence, which we can click through these and find. It's this base that we just looked at raised to the value of the layer you're at, and then times 10, just because everything is times 10. And then there's also some multipliers here. Let's see, this one is times 2. This is just a balance coefficient to get things balanced properly, and then par blocks per proficiency. This is kind of saying I expect the player to break this many blocks per layer, roughly, something like that. These two are not really important right now. So your experience grows exponentially with the base of your intelligence base. That's the point. Alright, so let's try to bring this back to idling and mastery and what we're all doing here. Based on your current experience that you have, based on your mastery, okay, I can back calculate, because remember your mastery is just all the experience you've gained so far. I can back calculate from mastery and find an equivalent layer that you're at, right? An equivalent layer to your mastery using this par experience equation, the inverse. So if I just put mastery on the other side of here, mastery equals da 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 da, flip it around. So n.q, that's just setting n equal to mastery because I don't want to change the mastery object itself. Divide by these values, and then take the log to the intelligence base. So this gives us an equivalent layer based on our mastery, which is interchangeable with experience. And then we'll do the same thing for proficiency. Using proficiency instead of mastery, we get an equivalent layer, D2. So let's name these better. Mastery layer, prof layer. So if our proficiency is greater than our mastery, then something is weird, and just return, and we don't give any bonus. Okay, so if assuming that's not the case, there's going to be some delta between these layers, and we want to move 1/1000th of the way towards the mastery, from the proficiency layer to the mastery layer. The important thing here is we're moving not in terms of experience, but in terms of layer. And then we're going to take that layer, n.q proficiency, why is this? It's doing anything. We're then going to take that new effective layer and then back calculate what's the proficiency we should have. Now, this is important because we're not, say you had 1e to the 1000, let's say you had 1e to the 100 mastery. Let's just say you had 100e to the 100 mastery, right? If we moved, let's say 1% of the way, let's say in our proficiency, let's say mastery equals this, proficiency equals 0. After 1 second, if we moved 1%, if we moved 1 over 100 of the way, of the delta, right? After 1 second, proficiency would be 1e 100, which is massive, right? And it would not work well at all, right? You've almost gained the entirety of your progress back in just 1 second. And if we made it so that, okay, well, let's say you gain 1 over 1/1,000,000th of the power. Well, yeah, that would work. You'd be at what, 100e to the 94. But what if your mastery is very low? What if your mastery is only 1e to the 6, right? Well, then you're only gaining proficiency of 1 every tick, and it's not going to change. And that doesn't work for a lot of reasons, because the proficiency you're going to be gaining as you break blocks is going to be huge. It's equivalent to your intelligence. I'm doing a pretty bad job of explaining this, but if instead we move 1 over 100 or 1 over 1000 of delta in terms of layer, then instead of being 100e99, it's going to be something ridiculously lower, like 100e to the 5 or something. Basically, I can show you this. Let me get an example real quick. So, if you have an exponential graph, and let's say we're at this point, 10, I think this example is going to work, although I just came up with it. Let's see. So, we're at 50. The value is 50. If we want to move 10% of the way towards 50, that's going to be 5, right? I know, amazing stuff, right? But actually, if we were traveling along the x coordinate instead, and we moved, so at 50, the x value is 40. If we move 10% of x instead of y, that's going to be x equals 4, and you see y is only 1.5. Okay, yeah, I think that explanation is much simpler than what I was trying to explain earlier. So instead of traveling 1% of, instead of traveling a fraction of the distance in y, or experience, we're going to be traveling a fraction of the distance in x, or layer. Wow, that was a lot simpler to explain. Hopefully you got it even now. If you don't, it's okay. I didn't really practice explaining that. Okay, we have 5 minutes left for the video. I'm going to try to wrap this up in under an hour. We'll see if I can do it. Alright, so now that we've explained all that, that's how this is calculated. That's what it's doing. So calculate the equivalent layer wrap for mastery, equivalent layer wrap for proficiency, take the delta, and then travel some fraction of the way in layer to find a new effective layer. We could just call this new layer if I wanted to. No, I guess this is the new proficiency layer. And then plug that into this equation again, base to that layer times these two coefficients. Okay, that's all what happens every single second. So now we need to do this in the IdleManager. We need to do this equation x seconds of times, right? So yeah, how do we do that, right? I mean, we could just make a loop here and call this, you know, n number of times if we have n seconds, but that's totally not feasible, right? That's going to be like potentially, you know, thousands and thousands of calls. I mean, it's feasible, but we can have a much more elegant solution. So the key is this part right here, finding the new layer. And the key is this factor, which is 0.001. This is an assumption that every second we're going to travel 0.1% of the way in x up that curve. So let's let this accept a time in seconds, and instead of traveling 0.1%, we're going to travel s seconds worth. So how do we do that? Well, this is some kind of geometric series or something like that. Let's see if we can figure it out. So let's make it. Let's every second, right? Or 0.001 every second. So so what's the total after 2 seconds? Let's say our total time 100 seconds. Let's say we're going to calculate the distance we want to move in x over 100 seconds. Well, after the first second, how much distance is remaining? 99.9%. Right? How much time, or you could say 0.999. How much time is remaining after 2 seconds? Well, follow the same formula, 0.999 times 1 minus 0.001. I say same formula, I didn't actually spell it out, but right? 0.999 times 1 minus 0.001. That's, or if you want to try to do it a little bit more simply, if this is the distance you have remaining, this times 0.001 is the distance you're going to travel. Therefore, the time remaining is, the distance remaining is 1 minus this. And I think it comes out to the same thing. I'm not actually sure. I'm having a brain fog, but I know this is the, I'm very certain this is the equation. And every time you're going to travel, you're going to reduce that gap by 1 minus this value. So what do you get? It's pretty, hopefully pretty obvious. 1 minus 0.001 raised to the s power. So that's all we have to do. So instead of multiplying by mastery bonus, so this is the delta distance we have to go. How much of that? So normally we're adding proficiency layer plus 0.1% of this, right? So 1 minus this raised to the s seconds. So this is going to be, so this is, if this is after 1 second, this value would be 0.999. So we want 1 minus that. After 2 seconds, right, after 2 seconds, that value is going to be like, let's say 100 seconds, that value is going to be 0.9. So that means and then 1 minus 0.9 means we're traveling 10% of the way after 100 seconds. So the nice thing with having this, I can just tweak this equation later on however I like. Tune this variable is what I mean. Minus 0.001. Is that right? So after 100 seconds, we're moving 10% of the way. So after 200 seconds, we should have moved like 20% of the way, right? Yeah. And after 400 seconds, what, 36% of the way? A little less, because each time it's 10% of the remaining. Every 100 seconds, 10% of the remaining. Okay, yeah, so that is that. That should do it. And so, back to the IdleManager. It's very simple at this point, right? Proficiency Manager dot apply this bonus for that many seconds. And I guess we can just make it a float. There's no reason. Okay. And we could just put these. Why don't we just make these? Let's make this a little bit more modular and not have the duplicate code. Every 1 second it calls that, so that'll just get plugged in there, and that should just become it'll just be equal to this, right? All right, that should do it for this video. Let's test. I guess I need to put some code in here to test, right? So, assuming proficiency is so n.q proficiency manager proficiency. Proficiency gain, apply mastery bonus, seconds, subtract out, negate. Alright, so let's see. Gain 13 proficiency after 34 seconds. So I have no clue if that is right or not. So let's try to set up a situation real fast in just a minute here that we can actually test. Proficiency manager.mastery equals, let's just say we have 1,000,000 mastery. Let's just say we have 1,000 mastery. And our proficiency is 1. And then let's just hack the preferences. Let's just hack this real quick and just explicitly say we want to idle for 100 seconds. So, we already did the math on that. It should be giving us about 9 proficiency. But it's not. Proficiency gain is 1. Okay, let's see if we can figure out what's happening. Let's just do this real quick, just to check that we're not missing something obvious. Okay, 1 proficiency we have. Gain of 1. Really? Oh, we're so close. This video's over an hour, but we're so close. Okay, so it's saying we gained 1. So that is indeed what it's saying. Let's just double check all this, and then we'll go through this code and see what's happening. 1k mastery. Okay, it's not obvious to me, so let's see. Let's just put a debug thing in here real fast. I think it's gonna be easiest. What are you even using N for here? I was using N for something, wasn't I? Huh. Okay, so mastery layer -16. Oh well, that would do it. Mastery divided by 5,000 divided by this, log this. I guess it's some value less than 1. The result of this is a value less than 1. So we get a mastery layer, which is negative. Proficiency layer, very negative. But I mean, the delta should still be positive, right? So prof layer is -65, -60. So, okay. So we went from -65. So -16 over -65. I think it may actually be working, but it's moving 10% of the way in X, not 10% of the way in Y. I think that's what is getting confused. Again, so 16 to 65 is 81 times like... Is that right? So this is the delta times... So it should move 7.7 in X. Something like that. So okay, I guess it is actually working. And that results in a proficiency of 1.9. Yeah, I think that makes sense. Because every second we're moving 0.1% of the way in X. After 100 seconds we move 10% of the way in X. But 10% of the way in X would mean that layer value has increased by, well, it's complicated, right? But the increase in Y is going to be much less than 10%. All right. Well, I think it's working. We could do more extensive testing and whatnot and confirm it, but for now, I'm satisfied. Regarding the game in general, there probably will be other idle components as well. Not entirely decided how idle I want everything to be. Whether it's going to be similar to IdleManager attack or even more idle heavy. We'll see. Like whether you'll gain power and gems and other things while idling, or just stick with more IdleManager attack kind of auxiliary idle benefits. But yeah, alright, I guess that wraps it up for now. Thanks for watching. I may try to do some more videos like this in the future, and hopefully if it's popular and I keep doing it, then I'll be working on the production values and get things to do good. But mostly this is just for my fun, for my enjoyment. Hopefully you guys got something out of it as well. If you liked the video, give me a like and leave a comment below or ask me any questions and I'll try to get back to you. Alright, thanks. Cheers!